Welcome to our final project presentation video. This class is EML3036, also known as Simulation Software for Mechanical Engineers, and our team is formed by Racheli Cejas Morales, Laura Angulo, and myself, Franco Melis. We introduce the project. I'm going to start off talking about us. We're a team of 3 students using SolidWorks for mechanical design simulation analysis. Our objective is to construct and examine a simplified engine assembly, studying the behavior of components through SolidWorks simulation. Some insights that we came across throughout the project were stress, strain, deformation, factor of safety, load factor, critical load and stress, optimization of dimensions or materials, and simulation studies on heat transfer and fluid flow. Before I begin talking about the results, it's important to note that the load value for all of the studies was determined by multiplying a moderate pressure, 400 psi, by the piston area, resulting in a load of 15556 pounds of force, while the temperature of the combustion engine, which is 4,500 degrees Fahrenheit, was used for the thermal study of the piston. Here you can see the compression study for the piston. Here you can see the thermal study for the piston, specifically the steady heat transfer in the piston. As you can see from the image, the piston experiences the highest amount of heat on the top, while the cooling system is working to lower the temperature around it. This is the thermal transient heat transfer study for the piston, and as you can see here, as time passes by, we observe that the piston's temperature changes. When it first starts experiencing the thermal load, the top heats up rapidly. After some time, the heat load extends itself to the body of the piston. Nonetheless, the cooling effect surrounding the piston lowers the high temperatures the piston experiences at the top. Here you can see the bending study of the piston pin. Here we have the compression study of the connecting rod. We continue with the bending study for the connecting rod here. Here we have the buckling study for the connecting rod. Here the bending study for the crankshaft is featured. Here we have the torsion study for the crankshaft. This one's an interesting one. This one is the design study for the torsion study of the crankshaft in an optimal scenario. It's important to note that there were 121 scenarios here. Therefore, the simulation took a lot to run. We are getting towards the end of our presentation. But as a last conclusion, we see this as a valuable project. We see that a successful construction and analysis of an engine assembly using simulation studies for mechanical behavior understanding is beneficial for the group and for their mechanical understanding of the world. Insights that we can mention are the crucial information on stress, strain, deformation, safety factors, and critical load, and an expanding understanding of thermal management and aerodynamics. Future recommendations can be to explore complex assemblies and dynamic analysis, utilize optimization techniques, and incorporate sustainability principles. for the future. Thank you for your time, and I hope you've enjoyed this video.